form an axial cell and a few peripheral cells. So that's all.
Namaste. This is JVA Dr. Vishal Saxena, Professor in Mathematics in JAYOTI VIDYAPEETH Women's University, Jaipur. So today we are going to discuss on the module regular Falsi method, and this method is also known as false position method. This topic is a part of the course numerical computation and running in the program of BCA 6th semester, and as well as uh, this regular Falsi method is also a part of the course uh, numerical and complex and numerical analysis in the BSc BA 8th semester of the university. So this regular Falsi method, which is also called false position method, is a method to solve the transcendental equations as well as the algebraic equations. And this regular Falsi method is similar to like the uh, bisection method and other method like the Newton-Raphson method. But this regular Falsi method is a important one because this method is having a this advantage that this method always converges to root, and this method is very easy to apply and for the computation way. So that's why this the regular Falsi method is a good method, and this will converge the root surely. So this method can be applicable. As already we know that the convergence in the bisection method is very slow. The bisection method means when we discuss about to apply and to get the root, then its convergence becomes very slow, and depending upon on the selection of the endpoints on the of the interval a comma b. So ultimately, just it will depend upon the selection of a comma b, and its convergence is slow. Therefore, bisection method is not giving the root the solution very rapidly. So therefore, regular Falsi method it can be applied in these conditions, and the function fx does not have any importance in determination of the point c, which is the midpoint of a and b. So it is useful only to decide the next smaller interval a comma c and c comma b. So just therefore this regular Falsi method is applicable, can be applied there because in the bisection method just the rule of this c is to get the smaller intervals, further smaller intervals like a comma c and c comma b where the root lies, and therefore a better approximation to the value c can be obtained by taking the straight line obtained by the joining the points a comma fa. So now a different approach means the different approach by this the root can be improved, and this is the regular Falsi method. So we understand here how can we derive the formula for the regular Falsi method. So first we are just taking a line, straight line that passes through the 2 points a comma fa and b comma fb, and this line also intersects the x-axis, is it? So this line also intersect the x-axis, and just because there at this point y becomes 0, so fx becomes 0, and the point x can be taken as a c point. Therefore, to obtain the value of c, we can equate the two expression of the slope m of the line. So we are assuming a line that passes through the 2 points a comma fa and b comma fb, and therefore this line also passes through the point c comma 0, c comma 0. Therefore just by these two conditions we are finding slopes there. So one of the slope m is given by fb minus fa upon b minus a, fb minus fa upon b minus a, and just by the method like y2 minus y1 upon x2 minus x1, and another the point of slope because the line is passing through the point 0 c comma 0, c comma 0 is lying on the x-axis, and another point that is b comma fb. Therefore, the slope can also be given by 0 minus fb upon c minus fb. 0 minus fb upon c minus b, and these are the two like different expressions for the slope m for the same line. So ultimately we can equate these two terms and therefore we will get c minus b multiplied by fb minus fa equal to minus b minus a into fb. So just means simplify this equation, and when on simplification this we will get the value of c as c equal to b minus fb into b minus a upon fb minus fa. C equal to b minus fb into b minus a upon fb minus fa. So in this way, this ultimately this is the formula for the root for the solution in the regular falsi method or the false position method. Now there may be further two possibilities for the next interval. Now the next smaller interval can be obtained for this root by checking these two conditions. First condition is if fa into x equal to 0, then the interval is a comma c, means the condition already we know that here for the root's existence in an interval, if f into fc is less than to 0 means it is negative, then definitely the root will lie in the interval a comma c. And if fb into fc is negative, is less than to 0, then the root will lie in the interval c comma b. So in this way we can find the interval in which the root lies, and therefore this method, this formula becomes and this is the formula for the regular falsi method. Now next advantages and disadvantages of the this regular falsi method. Look at this one. So advantages are, the first advantage is that this method is always converging method. So it is a very important pointer that this method is a converging method, and therefore when we apply this method, then the root can be obtained by this method. And second point is this method does not require the derivative term. So in this method, the derivative term is not required. And third point is this method is very simple in computation. So this method is not very difficult to apply, and can be easily and can be computed the calculations very easily. So these are the advantages point, and the disadvantages point are there. This slows down in unfavorable situations. This method slows down in unfavorable situations, and one of the interval definitions can get stuck. So these are the two disadvantages of this method. And now we take one example to explain this here. So using the false position method, find the root of the equation 2e raised to the power x into sin x minus 3 equal to 0. And the root is required for the three places of equations. So first of all, this equation is called transcendental equation because like here the simple equation in which the different functions are coming. So given equation is 2 into e raised to the power x sin x minus 3 equal to 0. And suppose the function fx is given by 2 e raised to the power x sin x minus 3. 2 e raised to the power x sin x minus 3. Therefore, f naught is given by f naught, value of f naught, because finally we have to check where the root will lie, in which interval the root will exist. So first we have to check, suppose if we take x equal to 0, then we will get f naught, and f naught is coming there minus 3. It means it is negative. And closer to 0, we take x equal to 1. So f1 is equal to, like you can see there, f1 is equal to coming there 1.5747. So it is 1.5747, and which is a positive value. Therefore the root of fx is lying in this interval. So root will lie in this interval 0 and 1 because f0 into f1 is giving us a negative value. So for this regular Falsi method, first we take there the values of a and b. So a is assumed to be 0 and b is assumed to be 1. Okay. So a equal to 0 and b equal to 1. Now the first approximation. The first approximation means x1. X1 is given by a into fb minus b into fa divided by fb minus fa. We have derived this formula just previously. Uh, look at this one formula here. So because the root is lying between the interval a and b, therefore the first approximation is x1 equal to a into fb minus b into fa divided by fb minus fa. Now what we have to do, just put their values a and b and fa and fb value we have to put and on solving this one we are getting the point x1 equal to 0.6557. 0.6557. Next again now we have to find the root, the interval in which the root will exist. So therefore, now this is the like the value 0.6557 is lying in a comma b. Therefore, now we have to break our interval a comma b for like a comma x1 or x1 comma b, and that can be checked by the method, by the root, by the concept that if fa into x1 is negative, then the root will lie between a and x1. If fx1 into fb is negative, then the root will lie in that interval like x1 comma b. So therefore, for this we have to find first its value fx1 means f 0.6557 and it is coming there. This is coming there minus 0.6507. So therefore, this value will become negative while f1 is a positive value, and therefore the root will lie between. In this way, one is the value 0.6557 and one is here f1. So therefore, the root is obtained, root will lie in the interval 0.6557 comma 1. Now again, the regular Falsi method is to apply here. So again, we have to give the notations. So now because 0.6557 is smaller than 1, therefore assume that A is equal to 0.6557 while B is equal to 1. And now apply the second approximation, that is x2 is equal to a into fx1 minus x1 into fa divided by fx1 into fx1 minus fa, and put all the values required there. Look at this one. So finally x2 is coming there 0.7563, 0.7563, and therefore 0.7563 is the value of x2. And now here in this way, because x1 and x2 are not very close to each other, so ultimately we have to apply our method further and till the approximation where the two last values becomes very close to each other. Okay, so now we have to go for the third approximation, and in the third approximation, the x3 is given by a into fx2 minus x2 into fa divided by fx2 minus fa. So in the similar way, just we have divided our the interval into the in which interval the root will exist. By the same method, we have to check where the root will lie, means like the x1 and like look at here, x2 is coming there 0.7563. So if 0.7563 and at 1 the function, the product of the function like f 0.7563 and f1 becomes negative, therefore the root will lie in that interval. And now we have to go for the third approximation x3, and in a similar way third approximation can be applied, and x3 will become 0.7675. Now we can observe that the last two approximations, mean second and third approximations, are giving the root in a roots value just close to each other, but not very close to each other. So we can apply the fourth approximation as well, and finally in this way we will get our root. But the third and the second approximations are giving the value just close to each other. Therefore, we are just not extending our process further, and with the third approximation method, with the third approximation, our root will become 0.7675 for the given equation, and by the regular Falsi method. So this is the regular Falsi method, and this method is a good one method, because in this method it has a very merit pointer that this method always converges to root. Therefore, this method can be applied to solve any equation applicable for this method. And in the next lecture, we will discuss about the different method for these two, from these two methods, Newton-Raphson and regular Falsi method, to solve this equation, algebraic or the transcendental equation. So with this, I am concluding my today's lecture. Thank you.